When we multiply monomials, we just use, this should be just use exponent properties. The number parts we would multiply, so -8 times 5 is -40, because all we're doing is multiplying all this stuff that's inside here. Then x to the 6th times x to the 3rd. Well, if I was just multiplying that, I have base to a power times the same base to a power. I can write that base one time and add the exponents to get 9. This question came up during the other videos. You do not have to put a dot in between there. If you'd like to put a dot in between there, you can. Either way is fine. Okay, then down here is going to make a little more space. When we multiply monomials with polynomials, so this one is specifically a monomial with a trinomial that has 3 terms, we just distribute. So I'm going to take 3x to the 4th and multiply it by each piece here. So I do 3x to the 4th times 2x to the 3rd would give me 6 when I multiply the 3 times 2, and then x to the 7th when I multiply the x parts. Then 3x to the 4th times -7x is going to give me -21 for the number part, and then x to the 4th times x to the 1st gives me x to the 5th. And then 3x to the 4th times 3 would just be 9x. And if there were any like terms, I would combine them here, but in this case I don't. Okay, next, multiplying binomials. The reason we talk specifically about multiplying binomials is because this kind of a problem occurs so often. There's 2 ways to think through this. Lots of people like and think and work with the idea of FOIL, where the F stands for I take the 2 first pieces in each parentheses and multiply them. So that'd be x times x. Then the O stands for outside, so I take the x times the b, so plus bx. Then insides would be the a times the x. Those 2 things are on the inside. Sorry, I got a little sloppy there. Writing with a stylus doesn't always go neatly. And then L stands for last. A is the last thing in the first parentheses. B is the last thing in the second parentheses. So I'd have x times x, or x squared if we were going to keep going, plus bx plus ax plus a times b. The other way some people think of this is they split apart the first parentheses and write each of those terms kind of spread out separately. So there's the x, there's the a from x plus a, and then they just double distribute. They take x times the second parentheses and distribute it one time. Then they take a times the second parentheses and distribute it a second time. And so I'm going to clean some of that away. But then what ultimately happens, so when I distribute here, I get x times x. Then I get x times b, which is bx. Then I get a times x, and then I get a times b, and it turns out you get the same thing both times. We get the exact same thing thinking of it as FOIL as we did by thinking of it as double distribute. So it totally does not matter. Neither one is faster even or more efficient. It's just a matter of how you organize the thought in your head. So we take one with numbers down here. I'm going to do the FOIL. That seems to be what more people are used to. So if I do firsts, 3x times 5x would give me 15x squared. 3 times 5 is 15, then x times x is x squared. O is for outsides, so I'm going to take the 3x and the -3, the 2 things on the outside from those terms. That would be plus -9x, or you could just write minus 9x, that's fine. Then insides here, 4 times 5 would be 20, and I still have the x. And then lasts would be 4 times -3, which is -12. Now the one thing we didn't do up here, up above, that we need to do now is combine like terms. Up above, we didn't have numbers in there, so combining like terms would get messy. Now that we're dealing with an actual problem, 15x squared isn't going to change, and the negative 12 isn't going to change. But in the middle, and this tends to be the case if you're going to have like terms, in the middle we have like terms. So negative 9x plus 20x would give me plus 11x, and then that would be my final answer. All right, and then the last kind of phase of this would be if you're going to multiply polynomials. And really, if you're going to multiply polynomials, we just kind of do a version of that double distributing. So in this particular case, we have a binomial times a trinomial. And what we're going to do is take the 2x and write it separately, and that plus 3 and write it separately. And then this x squared plus 4x plus 5, I put that in parentheses in each piece. So what I'm going to end up doing is distributing the 2x, then I'll distribute the 3, and then we'll just combine like terms at the end. So this is kind of just a bigger version of that double distributing we just talked about. So when I do it here, 2x times x squared would give me 2x to the third. 2x times 4x would give me 8x squared. And then 2x times 5 would give me 10x. And then that first chunk of the problem, that first half of the problem is done. Then I switch to 3 times x squared would give me 3x squared. 3 times 4x would give me 12x. And then 3 times 5 would give me 15. Whoops, that's a bad 15. Even with a stylus. So then I just need to look for different like terms. I only have x to the third here, and I only have a 15 there. Those two don't have anything else to combine with. But I do have x squareds that I can combine, and I do have x's I can combine. And then when we're all done and have combined like terms, I should write that in standard form. So what I usually do is look at the big long problem, figure out what my like terms are, and then just start with the biggest power and work my way down. So I'd start with 2x to the third. Then I combine 8x squared plus 3x squared would give me 11x squared. Then I go to my x's. 10x plus 12x gives me 22x. And then I have a plus 15 at the end. And that would be my final answer there.